Hi everyone, I'm McKenna, a postdoc working on usable security at Carnegie Mellon. Thanks so much for being here to learn about our work on creating usable tools that help ensure home automations are safe and working as intended. Now, I'm sure with so many devices on the market, everyone here is familiar with some form of home IoT if you don't actually own some yourself. There are smart voice assistants, various types of cameras, smart thermostats, locks, appliances, light bulbs, and even a smart fork. Now, typically, these devices can be added to your home network for remote control or integrated into other devices for new functionality. Or you can even customize the devices with automations, which is going to be the focus of today's talk. The types of automations we're interested in are written as trigger action programs, or we can also call them TAP, where the triggering event decides when the automation runs and the action decides what the automation does. For example, the automation on the last slide that I showed very briefly wakes you up slowly in the morning by having your light fade on. We can write this as a TAP rule. If the time is 7 a.m., then begin fading on light. The trigger is the time is 7 a.m. and the action is begin fading on light. You can also configure your home automations to work together with multiple devices. For instance, you can have Alexa notify you when a light turns on, hypothetically because your preschooler has gotten up after bedtime to play with her dinosaurs again, hypothetically. But with many automations, it can become really difficult to predict how your devices are actually going to behave. So if you installed both of those automations on the same light, you wouldn't just be woken up by this gently brightening light, you'd also be woken up by Alexa notifying you that your light is gently brightening, which is probably not what you really wanted and would be pretty annoying. But with other devices, we might have more serious risks. Like if you install this first TAP rule to lock your door every night at 7 p.m., and the second one to unlock your door when you get home from work, what happens if you get home later than usual one day after the first automation has already run? Or you get home at exactly 7 p.m. and both automations run simultaneously. When you go to bed that night, is your door going to be locked or unlocked? Now, prior work has shown that people are actually pretty bad at answering these kinds of questions, which pose pretty serious security risks if they think that the door is locked when it actually isn't. Now, researchers have developed a variety of tools to help people evaluate the security and privacy of their TAP programs. And one type of tool asks the user what kind of properties they want to hold for their smart home. So this tool would give you these templates like the one shown here, and the user would pick the template that most closely matches what they have in mind that they want their home to be doing. Then they would fill out the template so that the fields reflect the specific goal that they have in mind. In our paper, we call these declarative policies. Next, the user would tell the tool what rules they have installed, and the tool would tell them whether or not the rules will satisfy the property or not. Another kind of tool would look at the general shape of the user's program and try to find potential problems. For instance, if you had a rule which undid the behavior of the other rule, like this one, you've got one locking a door, one of them unlocking a door, and they might trigger simultaneously, this kind of tool would tell the user, this might not always work exactly the way that you want. In the paper, we call these tools, we say that these tools look for anti-patterns in a TAP program. And while there's been significant development in the space, both for tools checking declarative policies or looking for anti-patterns or doing some combination of the two, most of the work in this space has been from the formal methods side, looking at how we can build tools to protect smart home users. And we too have developed plenty of tools in this space. But the work I'm talking about today is an exploratory study of the usability and utility of the techniques employed by these tools, so that we can try to start bridging the gap between formal methods and usable security to take that work one step further to ensure that these tools can also be used effectively. Now, we split our study into 4 pieces, which roughly reflect the process of using these tools. And we start by asking some background questions on what goals people have for home automation. Next, we want to know whether users understand how to write policies using these templates that I showed you. And we also want to know whether users understand what it means if a tool tells them that it's found an anti-pattern. And finally, we want to know what kind of feedback tools can give users to best help them fix bugs that are found. The study is fairly involved, so to minimize fatigue on our participants, we split the study into 2 surveys. Both surveys start with these background questions on our participants' goals, and then we split the other tasks between the surveys. We recruited 174 participants for the first survey and 273 for the second survey, and our participants are real home IoT users recruited through Prolific using the gender balance sample. Now, in the interest of time, I'm only going to focus on the results of the first survey, so please feel free to read the paper or ask questions at the end if you want to learn more about the second one. Now, like I said before, we started by asking about our participants' home automation goals. We asked them both to rate the importance of some goal categories we've written for them, and we also asked them to optionally describe their own goals in their own words. And despite marking this question optional, 84% of people did give us interesting responses. Now, we asked participants how important they find goals related to home safety, home security, their privacy, comfort, and convenience, understanding device failures, or if they think it's important to use trigger action programming just for fun. For each of the categories, we gave them an example of a goal, and we asked them to rate its importance on a 4-point Likert scale, from this dark maroon color, meaning I don't care at all about this kind of goal, to dark blue, meaning I think this kind of goal is very important. And as you can see from all of the blue, our participants found just about everything important. They said safety and security was slightly more important than privacy, comfort, and convenience in debugging. But these results are interesting to us because it indicates that our users might be interested in a variety of tools. And also, interestingly, our participants do not think that goals relating to having fun are all that important. So we got some very serious participants here. Then when we asked them to actually write out what goals they have for their home automations, we observed that the way they talk about their goals varies a bit. Some participants just thought about their goals at a very high level, similar to the categories that I showed you before. This person said, I want my home to be comfortable and secure. Others talked about their goals as specific behaviors they want devices to be doing. This person said, I want my doors to be locked when I'm not home, and I want certain devices to be turned on at certain times of day, like a smart plug for my coffee machine. And yet others did a little bit of each. This participant mentioned a high-level goal. I want my home to be safe and secure while I'm away or sleeping. And they also described how they would have their devices do that. They want their doors to be locked in those situations. And these results are interesting to us because most of the participants mentioned specific devices when they're talking about their goals. And this is similar to what we would need them to do when they're writing declarative policies. Because when you're filling out these template fields, they need to mention specific devices and specific conditions. And this was the focus of the next part of our study. We wanted to know whether users understand how to use templates to write declarative policies. And we split this question into 2 tasks. In the first, we gave them a goal, and we asked them to pick an appropriate template format that matched the goal. In the second, we gave them both a goal and a template to fill out to match the goal. And this is similar to how they would write their own policy. First, they pick a template, then they fill it out. And overall, we learned that participants could generally pick out templates. In one scenario, we told them that the goal was for the lights to blink to indicate that smoke is detected in the home, but it should only blink for that reason. And almost everyone, 91% of our participants, did pick an appropriate template for this situation. But the results did vary depending on which scenario we gave them. For this other scenario, we told them that we have some automations installed that cause the lights to blink, but we don't want to annoy the neighbors too much, so they shouldn't blink for more than half an hour. And in this case, only 71% of the participants picked an appropriate template, but still most people were successful at doing this. Now, the other part of writing a declarative policy is actually filling out the template. Here we gave them both a scenario and a specific template format that we wanted them to fill out. And again, we see some promising results. In one scenario, the policy should indicate that the windows should be closed while it's raining. And for one of the template formats we gave them, 97% of participants wrote down an appropriate policy. But again, the results varied depending on which template format we gave them. Another template format for the same scenario was only filled out 37% of the time correctly. And similar to the policy, the template picking task, the template filling task did vary depending on which scenario we gave them. So for the second scenario, we told them that we don't want the dryer to turn on during the day because it might interrupt the Zoom calls, and success rates ranged from 12 to 75%, depending on which scenario or which template we gave them. But depending on the scenario and the template, people could sometimes fill out the template. It's just that they struggled sometimes with some templates more than others. Now, we wanted to learn about what kinds of goals our participants have for home automation and whether they can use templates to write declarative policies. The results of our first survey suggest that at least with some refinement, people might be able to write declarative policies which reflect their home automation goals. Participants value the kinds of goals that can be expressed as declarative policies, and they even think about their goals in a way that's similar to the way that these policies are written. They were even successful at many of our tasks, but there is also definitely room for improvement. The mistakes people made when they were filling out the templates showed us that there is more research needed to ensure that the way that the template is written matches the policy that's actually being checked by the tool. Our results also highlight some confusion regarding the relationship between home automations and policies. A lot of people were writing these policies as if they were writing a TAP program, but that is not the way to approach these tools. And while I didn't really have much time to discuss the results of our second survey, one clear takeaway there was that the short description and example we were giving people was not really enough for them to understand anti-patterns. So we do need to do some more research here as well. Now, this is a really exciting and important area of research because home IoT can be used to help keep us safe. And this goal was definitely echoed by our participants. But home IoT is only protecting us if it's operating the way that we expect. Before doing the survey, we had some evidence that having tools is more helpful than not having tools, but it wasn't really clear what approach these tools should be taking, and we didn't know what kind of problems people would run into if they use the tools. And now we have a much better idea of what is working well and where we need to do a little bit of more work. The data we collected is available online for all of the participants who agreed to have us publish their results. So to learn more about our results, I want to encourage everybody to check out our paper and look at the data, and please feel free to ask questions. Thank you all.